Today what we're going to be talking about is perimeter and area. Okay, we're pretty much going to be talking today on perimeter and area of squares, rectangles, and maybe some odd looking shapes. Okay, starting next week we're going to bring in some triangles and circles. Okay, but we're still going to do perimeter and area. Now when we get to circles, it's not called perimeter, it'll be called circumference, so you'll hear a different word, but it's kind of the same meaning as what perimeter is. Okay, so in your notes, you need to write perimeter. It is the measurement of the distance around the outside of the object. Okay? In which this case, the object that we're talking about, that we're going to be talking about today, is going to be our squares, our rectangles, and maybe some weird looking shapes. But they're going to pretty much be square, straight edges. It's not going to be triangles. Okay? To find the perimeter, there should be an E right there. You add all the sides together. We have a couple of formulas we can look at, but on perimeter, if you'll just add all the sides, you're okay. So a formula well, so far we've got three different things. It's not one run-on sentence. Okay. So formula for a perimeter of a square. Okay. Usually we use the word P, telling people that's perimeter. And we do that because what letter does perimeter start with? That's why we use a P. Okay? Is 4S. Now let's think about it. What do you know about a square? Has 4 sides, so that's where 4 comes in, because it's 4 sides. And why would they all be multiplied by S? What do I know about a square? Is 4 what? It does have 4 sides, but 4... What's the difference between a square and a rectangle? Okay, so help me go back now. What do I know about a square? It has 4 equal sides. You kind of got it after I asked you what the difference between a rectangle and a square was. But remember, a square has 4 equal sides. So that's why I'm just able to multiply 4 times S. Okay? That adds up, because if I have a square that was 2 by 2 by 2 by 2, I can add them all up, or we know if I'm adding 4 of those, I can also multiply, correct? So that's the same. So you could do either one, but that is a formula. Only with squares can you do that one. Okay, now we have a rectangle. And Austin up here told me a rectangle has a long side. So that's what made it different than a square. So my formula for a rectangle, again, I'm starting with P, which stands for perimeter, is 2 times the sum of the length plus the width. Yes, and L stands for length because length starts with the letter L. And with starts with the letter W. So that's why we use L and W on those. Okay, that turns into a three-dimensional figure. And at that point, then, if we want to fill it, it's going to be a volume. So we're not talking about perimeter yet. Okay? Perimeter is just measuring the outside of that figure. Now, let's look at one. If I have a rectangle, and this was 10, and this was 4, sometimes they don't give you this side. But we know, because it's a rectangle, what would this side be? Listen to my question. Listen to my question. What unit? 10. And so sometimes they'll leave it out, and they make you place those numbers in there. Now, typically, I could add all sides. So 10 plus 4, 14 plus 10, 24 plus 4. Okay, so if we added all sides, we got 28. Now, if we used our formula up here, okay, first thing you always need to do is copy just the formula. Don't replace. Second step, start and replace. What's the length of this box? 10. And what's the width of this box? Now, using correct order of operations, what do you do first? You do what's in parentheses, so you're going to add these. So I would get 2 times 14. And then next order of operations tells me I'm going to have to multiply. So we're still going to get the same thing whether we use formula or we use just adding all 4 sides. Okay? It wouldn't matter. Okay. Once you plug in right here, you always go back to order of operations. Always. Anytime you solve a problem, you always got to use correct order of operations. Yes, sir. As soon as you plug in, you always use order of operations to solve your problems. Okay? All right. You may have a question on that, on perimeter. Okay, here's some words that would mean perimeter. And why would I be telling you this? Because if they give you a word problem, they may not say find the perimeter. They may use other words to ask for perimeter. Words that mean, it should be an E, perimeter. These are edge. What is the edge of the yard? Okay. Outline. Rim. Surround. Fencing. And that's one. Somebody's fencing in their yard. How much material would they need? Fencing is a sport, but in this case, how I just said that, I'm going to be fencing in my yard. Do you think I'm going to stand out there and fight? Or do you think I'm going to put actual chain link fence or wood boards around my yard? Okay, so you have to pay attention to the context in that one, okay? Outside. Around. Border. Or frame. Okay, all those, so if in the word problem, if you're picking up what they're talking about right there, that may be meaning they're trying to find how much. If I was going to put border around this room on the walls, I would be talking about perimeter. Because if you think about it, like that wood board that goes around the room, that's almost like a border. Okay? So I've got to have the length of that wall. I've got to have the length of that back wall, the length of the side wall. Okay, and if they put it on the front board, if no chalkboard was there, I would have the length of that wall, correct? So that would be, and they technically did, kind of underneath. Okay, that means the perimeter. Okay? distance around, but again, we use the word around, okay? So those all mean perimeter. Do what? I don't know what you're talking about on that. Oh, the border around the chalkboard. Okay, that would be a perimeter around the chalkboard, yes. I see what you're talking about now. When you said chalkboard, I was thinking you were meaning area. Yeah. Okay. Anybody have a question on perimeter? Okay, now we're going to talk about area. This measures the inside of an object or shape. Now, these are all two-dimensional, meaning they're a flat surface. Okay? This is three-dimensional. Okay? This piece of paper is a two-dimensional. Okay? Because, well, look at my difference. What do you see in this cup that this piece of paper doesn't have? Height. Okay? It has the height. There is a weight difference, but I can feel both. Okay? But this is on a flat surface. There's really no height to it. There is height here. Two-dimensional just means I have two sides to it. I have a length and a width. I have I have two measurements to it. Three-dimensional means cup's not the best thing to use for that. Let's use this. This is three-dimensional. There is. Okay? And it goes in 4 different directions. Okay? Typically, we don't see the 4-dimensional. Okay? But you can graph 4-dimensional. And if you ever get to calculus and trig and things, you'll actually start to graph in 3-dimensional. 4, maybe if you do some engineering kind of stuff, but okay, it pretty much stays 2 and 3. That's 3 because I have a height to it. I build off that base. Uh-huh. Well, but if you think about it, if you look at my bottom, I have a length and a width, right? But then when I turn it this way, you see it just kind of keeps stacking on top of each other. Okay? So that's what makes it that 3-dimensional, because I have a third direction in that way that box is going. Okay? All right. Now, typical things that we see in area is to cover the inside of something. Oh, don't you look good? Woo! Kind of a little flashy over there, aren't you? Was that from your secret pal? How sweet. Yeah. Okay, so when people think about carpeting a room, we're going to retile this floor. We're talking about area. Because we're covering the bottom part from one wall all the way around inside. Okay? So border is on the outside. Area is the inside area. Okay? All right, now there is some formulas for area. Okay? We'll start with square because that's what I started with when we talked about perimeter. Everybody remembers what a square was, right? It has 4 what? Equal sides. So, let's think about this. If this was 3, what's this side going to be if it was a square? 3. Now, mine's not a perfect square because I freehanded it, so it's not a perfect square, okay? But everybody knows that, right? Yes. We won't get to it. You might if you get into calculus or trig, but very rarely. It'll probably be higher up. Okay, so for a square, my formula for a square, okay, is going to be, actually leave that, we're going to come back to it, because I want to walk you through how you're going to figure it out. Rectangle, one side was longer than the other, right? That's going to be length times width. Now, if this was 10 and this was 4 like we had a minute ago, it's not 10 times 4 times 10 times 4. It's only one side of the length times one side of the width. So that's just 10 times 4, which we know is 40, correct? So now let's think back. A square kind of starts out with the same formula, but we know a square has 4 what? Equal sides. So if the length was 3, we know the width is 3. Well, what do I know about 3 times 3? How can I write that in exponential form? No, that's your answer. How can you write it in Okay, somebody said 3 times 3, which is right, but I want an exponent in there. 3 to the second power. So a square formula, and they like using the word S because they're talking about a side of a square, and they square it. Now, if you use length times width, you're going to get the same thing as you have here. So I'm going to actually write them both here. Length times width. But they both mean the same thing. S is the side, the length of the side. Okay? That could have gave me the length. That could have gave me the width. Okay? But we know because it's a square, it's the same no matter what they give you. Okay? So that's kind of why they put an S. Okay? Instead of an L squared or a W squared. Okay? That's why they use the letter S for a square. Anything else, they'll give L and W. Okay? Yes. And you're still going to get the same answer. Okay? Square, we just know they were going to be the same number. Okay? Rectangle, they're going to be different.
Is equal like a keyword?
What?
Is equal a keyword for?
Equal?
Yeah.
Equal just tells me that they're the same. Okay? And because these two sides were equal, they're the same. Because they're a square, and they have 4 sides that are the same. Okay? We will get to that, yes. Okay? But we're kind of just starting off basic right here. Alright, now here's some words that mean area. Okay? Inside. Face. And face will come into play when we talk about 3-dimensional objects, okay? So we'll talk a little bit more about that word face. Surface. Anything that covers the entire surface. All of this is together. So this is more like a phrase. And what that one might be is if they're, how much material would I need to cover the surface of the bottom of this box? Well, what they're talking about is using area, so I'd have to do length times width. Okay, because I just want the bottom. So if they use that in a long, drawn-out sentence, how much material would I need to cover the entire bottom of this box? Okay, they're meaning area. Perimeter. Area and perimeter. Alright. Everybody see A up here? Okay, sometimes they'll give you drawings. Now, like they did these little boxes. Okay? And so what they want you to do is count. If I ask you the perimeter of this box, you're going to count the boxes. So how many boxes did I use on this outside? 3. I'm going to try and write on this. Okay. How many did I use here? How many did I use here? 3. And how many did I use here? Okay, what shape do we just make? A square or a rectangle? A rectangle. Okay, now, two different ways I could do it. To find the perimeter, I could add 3 plus 2 plus 3. So we have 5 plus 3, 8, and 8 plus 2 is? Okay, or I could choose to use my formula and plug in. So if I did my formula, what's the length? Okay, and it doesn't matter if you want to do 2, that's fine. I would know then the width would be 3. So it really didn't matter. Order of operations tells me to do what first? Add, so parentheses, 2 plus 3 is, and now I times it by 2 and I get, and what did I have a minute ago when I added up all the sides? 10. Okay, that's my perimeter. Yes. Okay, do I have a question on that one? Okay, let's look at B. What's the length? I mean, what's my unit? How many? How many? 5. How many? How many? So to find perimeter, I can either add them up or I can use my formula. So 12 would be that one. Okay? Alright, what about F? It's a square. Okay, or I could 3 times, how many sides? There's 4 sides, so 3 times 4 is, not 3 to the 4th power, because that meant 3 times 3 times 3 times 3. I'm finding perimeter, so I'm adding all sides, so that's going to be 4 times 3, which is 12. Okay? Anybody have a question on perimeter? Okay, let's go back. Same figures, we're going to talk about the area. What's the area? You told me this was a 3 by 2 a minute ago. How'd you get that? 3 times 2. Now, no. Area you have to multiply. Now, if these are shaded in right like this, you can just count the inside. So 1, 2, 3, 4, 5, and 6. That's how much is covered on the inside, okay? Now, that's okay as long as they have equal, consistent blocks like that. But what's going to happen is they're going to give you a shade like this and give you 3 times 2. Now, can you count how many blocks are in there? No. Okay, so if they got blocks, you can do that for area. You can just count the inside blocks. But if the blocks are not there, you have to know what to do, which is multiply. Okay, look at B. We said that was a 1 by 5, correct? So the area is 5. 1 times 5 equals 5. What about F? That was the square. So I could do 3 to the 2nd power. So that would be 9. And again, I could account it because it's a square. Because if I did length times width, that meant 3 times 3, correct? And what is 3 squared? 3 times 3. Okay? So if I've got a square and I know one side, I know I can go straight to my formula. Okay? Any question on that one? You have sat in here for 46 minutes and didn't have your glasses on? And you just now realized it? Yeah, go get them. Alright, I am going back to our smart board. Let's see if I can pull up that little chart. trying to pull up one of my 100 block. Did I just pass it? Ah, right there, thank you. Oh, no, not that one. Alright, so we know that there's 100 blocks in here, but let's say I have some funny design. Let's say I have these two, and I'm going to come down in here. I'm going to shade this way. Yeah, that's what I'm trying to do, is get a weird shape. Alright, let's say that was colored in better, okay? My scribbles are going to turn into great shading ends, okay? What is the perimeter of this object? What is perimeter finding? The measurement around on the outside. So pick a spot to start. It doesn't matter. So we're going to start right here. Alright, so let's count. 1, and I'm back to where I started, right? So how many units around that object? 20 units. Okay? Did you see how we got 20? Okay? Now, what you could have done, you could have counted and said, okay, well, that one's 2. This is 1. This is 1. This is 1. That's 1. You could have broke down and done that.
Oh, I see.
And then you could have just added all those. Okay? Or did like we did with the object and just counted the outside blocks. That is an irregular shape which does not have a formula. Okay? Now, how would you find the area? Count all the inside ones. So,
1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
so how many units? 16. Okay? Everybody see the difference between those two? Okay, good, because you have a worksheet to do right now.